Hello, welcome to Enlightning. I'm here today with Peter O'Neill, who's going to teach us about open policy agents, which we call OPA. OPA! Yeah. Tell us
Definitely a
about
joke I've heard a lot.
I'm sure. But it's like I'm excited and I'm
Oh
handed a
no,
word to
it's so
say
good.
in that
It's so good. I
excitement.
hate like you see all the community members who get excited about it and they'll post like a store or a restaurant that's called Opa.
Oh yeah, we have one of those here in Austin, Texas. Yep.
Yeah.
Um, Peter, thank you for being here. Thank you for sharing your time and your expertise with us. Tell us about yourself, please.
Cool. Thanks for having me, Whitney. So I
Yeah.
am a senior DevOps engineer at a consultancy called WebRight. And yeah, I've been working with Open Policy Agent for a couple of years now. I've been heavily involved in the community, getting people started and onboarding, kind of evaluating whether it's the right tool for them. And so doing a lot of our community engagement, whether that's like conferences or just like through the Slack or through GitHub, and kind of just working with the community members to get them involved and ramped up and kind of understanding and using the technology.
Excellent. Awesome. So, case in point right now, being involved with the community, you're doing it
Yes.
currently.
Yep. It's
um,
kind of just this, the different format, but same thing.
so one thing I think is cool about you is that you spent some years as a digital nomad. Did you do that while you were doing this community job?
I, Interestingly enough, I started this job at the tail end of my digital nomad journey.
Mm-hmm.
And kind of like the funny thing was, as an advocate, you travel a bunch, and as a nomad, you're always
Uh-huh.
traveling. And so
Yeah.
that line between work
Uh,
and play got very
uh-huh.
blurred, and it was very hard for me to like keep track of where I was supposed to be at any given time. And so I ended up like moving to Denver and kind of just like settling down just because, right, like the joys of being a digital nomad are all about just packing up and going wherever you want, whenever you want. And when I had a
Ah.
schedule of conferences and events and things, it's like I lost that ability. And then it was just
Yeah.
me being homeless while having a full-time job.
But saving a lot of money maybe in that process.
uh, I mean, sometimes it depends how expensive the city was that they sent me to, and so there's just a
Yeah.
lot of logistics. Yeah, actually, I got this shirt as a digital nomad from the Galapagos, and so it's
Oh,
kind of
cool.
a like a nice homage of like there's like this guy at the bottom, kind of just like one of the first like submersible suits, and then like the space suit, kind of an homage to like humans exploring places that we've never we shouldn't be exploring, right? Deep space, deep
Uh-huh.
ocean, kind of. I don't know. It was just like a cool shirt when I went to the Galapagos and was seeing all of these super fascinating like marine biology. Like it was a very cool place. If you don't have it on your list of places to go to, I recommend it. Mm-hmm.
It's on my list now, my very long list. Uh, I have questions. Well, I wanted to say I relate to you. I lived homeless for a year or two when I toured in a band. So I also lived in a van for a year, but it was very different, I imagine, than digital nomad life. But how did you have like a van that you outfitted for to be able to work from? Is that your strategy?
I so digital nomads normally either pick like van life here in the US, or it's
Mm-hmm.
like cheap international life, right? And so
Ah.
I did a couple of van trips. One I spent 6 weeks down the coast of Australia, and then 3 weeks down like the center of Patagonia. And
Mm-hmm.
so
Cool.
I like, but both of those times I rented a van specifically for those trips. Most of the time it
Mm-hmm.
was finding an apartment in like Thailand or Japan or something for a couple months, and just staying there long enough to build a working groove, and then go to the next place.
Mm-hmm. It sounds like maybe like would you do it again? Not necessarily those trips specifically, but like that digital nomad lifestyle.
In the right context, I would. I think that if I did it again, I'd probably want to do it in the US this time. Like I had a lot
Mm-hmm.
of fun uh going through Asia and like seeing a bunch of stuff that was kind of culture shock. That's what I was looking
Mm-hmm.
for. The first place that I picked was
Mm-hmm.
Vietnam, and wanting to like see something that just like felt very different than what I was used to. And so I
Yeah.
really got the experience that I was looking for out of that. And
Uh-huh.
so I wouldn't be looking to create those same experiences. What I'd want now is maybe to see my own backyard a little more, right?
Uh-huh.
To see a lot of like the cool features that we have here in the US and a lot of the national parks, and right, and there's like each one of these states is like its own country. Like there's just so many like unique things about them that I would
Yeah.
love to go and explore. And I've seen more countries than I've seen states.
Ah.
So it's like
Right
so maybe like yeah, going back and revisiting some of the things in my own backyard might be nice.
Cool. Fuel Snobel's here. Hello, Fuel Snobel. Thanks for coming.
Hey.
If anyone else is here, please do say hi and tell us where you're from. Come join in the chat. So we talked about your past life, and let's talk about your present. Tell us what you're doing now, and what you're currently working on, both from like maybe what conferences you have coming up, and then I'm interested in a DevOps consultancy, like what that actually looks like in practice too. And I'm going to start moving behind the light board.
Yeah, that sounds good. And so, this is a relatively newer thing for me. I've been in this role for less than a week now. And so I still do a little bit of the advocacy work. I actually have a conference coming up next week at Devops Days New York, where I'm talking about the differences between auth with an N and auth with a Z. So that'll be Devops Days New York. I think it's on the 7th or 8th. But yeah, and so I'll be there. If anyone else is there, please come and say hi. And I'd love to chat with you about OPA or auth or anything DevOps related. So right, like as a DevOps consultant now, I get to do a lot of what we call digital transformation. And so digital transformation is kind of taking companies that have a bit of technology debt or right needing to move more into the cloud space. So it's companies that maybe have not quite containerized their applications or right adopted best practices on any of the cloud platforms yet. They haven't built out their CI/CD platform or developed ways of working that are that cloud native kind of mindset that we talk about a lot in the CNCF, right? And I think that's something that maybe is taken a bit for granted, because it's like when we're talking to all of the other people in the CNCF, we're all in that cloud native mindset. And so there are still a lot of companies that have not. Yeah, go ahead.
A related thing, Fuel Snobel has a question. How do you define DevOps?
Cool. Yeah, I mean, there are a lot of ways to define DevOps, and it's very different coming from different people, what they would describe it as, right? The simplest definition, right, is that combination of development and operations and the meeting point between the two. So it is developers building an application and then ops building the infrastructure underneath it. And what does it look like to create infrastructure in the middle that helps both of those teams, right? And so typically when we're doing DevOps transformation, we are understanding what the application looks like and how we can help them get to a point. And typically this involves a lot of like automation tools, kind of like Terraform or Argo CD, right? And you're being able to deploy things now in that automated fashion. And so that's why automation and DevOps typically get smashed into one thing, is because we're building that bridge between these two teams and how exactly they're going to operate and communicate and best manage that application.
And then Fuel Snowball also wants to know what are things you should do and things you shouldn't do.
In DevOps?
Presumably. Maybe if you want to say in life in general, I'm interested.
Yeah, I guess things you shouldn't do in DevOps. Well, I don't know. Like DevOps is all about building best practices around things that you should do, right? And so I guess the things that you shouldn't do are the things that we're trying to transform, right? And so the things that we're trying to build away from are things like silos, right? And so this is a very common word you hear in DevOps is the different teams. It might be security, engineering, application, infrastructure, like all the different teams. If they're siloed and they're each looking at their own component of the company, right, it becomes You said we love silos, and that's kind of just funny. Right, and so like this is a thing that happens happens without even trying, and it once it is there, right, like then you have to figure out how to break down these walls, because you have that natural propensity to these walls going up because everyone's so focused on doing the best job that they can do and their team can do. And so when we're doing these DevOps transformations, we're trying to help break down these walls and understand what each team is responsible for and how we can enable them to work with these other teams in a more seamless fashion. And typically, we look at tooling a lot because that's the simplest way to get information from one team to another without having to say like, oh, this is all your responsibility, right? Having that common set of tooling allows these teams to collaborate in a way that brings down those walls, where it's both teams can look at the same configuration data, they can look at the same database, they can look at the same like construction. And so that way, right, we kind of have that much more fluid nature of the application getting deployed. And so that's why the tooling and DevOps typically very much get shoved into the same bubble when people are talking about them.
I want to say hello to Kaiwalia. Thank you so much for coming.
Oh, hey, Kaiwalia.
And then I want to add to something you should not do, or folks are trying to get away from, which is to do things imperatively and to run a lot of scripts. Like you're trying to do more declarative infrastructure as code, GitOps style resource management, we'll say. And then Fuel Stumble has another question. You say both teams. What are those two teams?
When I say both teams, I am just referring to any two teams that are on opposite ends of a silo, right? Like, and so when we talk DevOps, we might be talking development operations, but it could also be development and security, or operations and security, or just like, I'm just talking about two teams on different sides of a wall, right? And so those are the walls we're trying to bring down and get all of the teams to collaborate, more of like a mesh system. So I'm not specifically talking about any two teams, just teams behind a wall.
Excellent. All right, let's dig in on Open Policy Agent. So I love to start this part of the show by asking you a question. You know me well enough to know I'm pretty new to this whole cloud scene. And so what was the world like before Open Policy Agent that made Open Policy Agent get created?
Yeah, definitely. And this is kind of an interesting question, because it is policy as we know it today, right? Is something that we all kind of understand that, oh, we need these guardrails around our development practices, right? And so before we had this defined policy languages, right, people were developing policies in, right, like directly in the code. And even before that, you might have written your policy in like a wiki, right? Like you might have just said, like in some sort of internal knowledge base saying like, oh, hey, you know what? No deployments to production on the weekend. So we don't support that, right? And so that would have just been something you wrote down somewhere, and people were just expected to follow it. But right, like even for some of my first jobs, I had root and admin access to everything, right? And like that was just like that was the easiest way to get things done. And so like I just knew the rules were written down in a wiki, and then when you broke them, you're kind of just like, oops.
Your hand was slapped.
Yeah, you're like, I didn't read the wiki well enough. And right. And so this idea of policy comes from this process not working very well, right? Because slapping someone's hand is not as effective as having direct and immediate feedback when you do something bad, right? Or when you do something you shouldn't. Maybe you don't know it's bad, or maybe it's not bad. Maybe it's just not best practice. But when you're deploying resources and you don't tag it correctly, right? You want the system to tell you that there's a better way to do things. And so, right, like that's something, that automated fashion is kind of where these policies came from. And the idea of Open Policy Agent kind of comes as an extension of this, in how do we do this across our entire tech tool stack, right? And so Open Policy Agent came about because once we started defining these policies and in specific technologies, now we wanted to say, hey, I have policies hard-coded in 12 different places. Can I define this in one place and then use it for any of these tools?
So were there policy tools before Open Policy Agent, or is Open Policy Agent one of the first?
I don't know what the first, like if we're talking about a decoupled tool,
Uh-huh.
like I'm not sure which ones would have predated it. Like there would have
Mm-hmm.
been like systems, like hand rolled systems where you
Mm-hmm.
might have had a centralized system to check things, right? And so from that perspective, that could have been a decoupled policy kind of placement, but it's not
Mm-hmm.
exactly designed in the same way where Open Policy Agent integrates directly and natively with each of these tool sets, right? You find a way to have the tools that need policy decisions reach out to Open Policy Agent, right? And so OPA, right, I think it's 6, maybe 7 years old. And so from that perspective, I was not doing a lot of policy work a decade ago, but right,
Mm-hmm.
like I know that the tools were very primitive, and so I know that Open Policy Agent became very popular because it was, if not the first, one of the very early decoupled policy tools.
Cool. So decoupling, I think, is I want to capture that word. Cool. So before Open Policy Agents and before like policy tools generally, policies might be hard coded, like written directly into code, or they might be even worse, like in a wiki, like suggestions that you should just remember and follow.
Mm-hmm.
So there's a need for policy automation, but also across a tech stack. So there's like a central place to define policy that can be used all over the system.
Mm-hmm.
So decoupling the policy itself from the services that might need to use it.
Yeah, perfect.
Feels novel. This might be a tongue-in-cheek question. So you have policies that prevent deploy on weekends.
I mean, it depends if you want to give your engineers a break.
All right. So I would love to say, what is Open Policy Agent? Let's get a nice solid definition up on the board.
Yeah, and so the most concise definition that we use is just OPA is a general purpose policy engine.
So by general purpose, are you saying it's not for Kubernetes specifically, or are you saying more like speaking more about this decoupling aspect?
So it's the decoupling aspect, and then it's also, when we say general purpose, right, there's kind of this interesting side effect there where the tools, while we use them for policy, right, they're general purpose in that I've seen people use it for things that are not policy, right? It's general purpose because both of these tools are so flexible, right? We have OPA and Rego, and they're both designed to be very flexible for their portion of this. And so you can do things like I've seen people create, like game solving engines, people doing gambling statistics or generating like sports metrics, right? Because they're just like, well, it's a general purpose tool. All I need to do is feed in some data and it will give me answers. And so it's like, it's not even necessarily just for policy. That just happens to be why it was built, right? So it is a general purpose, like you might even say decision engine, right? But obviously we know it as the policy agent. So that's kind of where we focus all our attention.
Interesting. Sometimes when something can do everything, it can be hard to figure out what it is.
Correct.
Yeah.
There's a lot of those, I guess, double-edged sword situations between OPA and Rego, where we give you the flexibility of the tool, right? But we give you so much flexibility that you don't necessarily always understand the trade-offs, right? There's a lot of trade-offs between readability, performance, and extendability, right? And so you have these trade-offs. And as a new person who's trying to learn, well, how do I deploy OPA? How do I write Rego? And now do I also need to figure out how to make this performance and extensible for future iterations, right? And so there's so many components to that it becomes a little overwhelming for a first-time engineer that doesn't have the guidance to learn it, right? If they're kind of coming in and just like, oh, let me just like create stuff, and they're just like, oh, but I can do this, and I can do this, and I can do this, and they all do the same
Yeah.
thing. And so it's like, that's one of the things, like as like a community manager, community helper, I get to explain to a lot of the new people.
Yeah. So a couple of things. One is, I think I want to get a definition for Rego on the board too. And then after that, maybe, because, okay, on purpose, I don't learn about tools before these moments. So you're telling me such a broad definition of what it is that I actually don't have a good grasp on what it is. So maybe we can go into a couple like popular use cases for OPA as like just a way for me to grip onto something. How does that sound?
Yeah, that sounds good. So we can define Rego, and then maybe I'll define the 3 kind of segments of a policy, and then
I like it.
And then we could talk about specific use cases or like deployment patterns, because it's helpful to understand what goes into a decision, so that then we can take that knowledge and layer it on top of the use cases.
Okay, I love it. I love it. It's like you've done this before.
Once or twice.
Okay, what is Rego, please?
All right, so Rego is the purpose-built declarative policy language, right? And so when we're talking, right, once again, this is like a concise definition, and it's purpose-built because it was created specifically for Open Policy Agent, right? The creators of OPA went through the exercise of like trying to see if an existing language could be used. The problem being that each coding language comes with its own sort of baggage, right? And now you have to define what that baggage looks like in this policy language, and what things work and what things don't. And so that ended up being a bigger lift than creating a language specifically for OPA, right? And I think it was based on a language called Datalog, which is basically like a configuration language. And so, right, and so we've created this language, and the nice thing about it is, right, because we're building from scratch, we can add things on in a modular fashion. And it's also, you said this word earlier before we started writing on the board, declarative, right? This is the declarative language, right? Which is very cloud native, as you would, right? People like things in a declarative fashion that are reproducible. It's documented as code, right? Like all of those things that we've kind of gotten used to, right? So but the modular piece of this is that as the community members started, using this language and adding new use cases, they started adding modules and adding things, right? So it started off with a handful of built-in functions, and now I think there's over 150 things that have been added to the language for people saying like, I'm working with specific data types, and I want those data types to be handled natively inside of Rego. Okay.
Cool. We have Nick, the first one's here. Hi, Nick. Thanks so much for coming, friends. And Fuel Stumble, the computer engineers ask themselves, can an existing language be used? The answer is always no.
Everyone wants a new DSL.
Excellent. So Rego is declarative purpose-built policy language. Do you think there's more to say about like the functions built in, or that's how it's matured, or anything like that, or should we leave it at this?
I think probably like a closing note there on like how it's matured is that as it's gotten closer and closer to the V1 release, they've added a lot of syntax features that make it more closer to the human English language. And so that's kind of like a nice thing that's been added on to make it much more readable. And so we do that by just doing like import future keywords, and that gives you kind of access to those new features without breaking backwards compatibility.
Cool. All right. Okay. Three parts to a policy.
Oh, right. Okay.
And so time?
Yes, it's time for that. And so this is kind of like the policy triangle, or like decision triangle, if you will, right? And so anytime you're reaching out to OPA, right, you're looking you're looking for a decision, right? You want to know, should something happen or should something not? And this is kind of the simple definition. If you're looking at like the complex definition, which we might dive into a little bit later, is like you're actually just doing data transformations. But on the simple side, right, we're just asking OPA for a decision, right? And we want to know, we have an output that we want to know, like, should this service do something? Should, access be allowed? Should this data, move from one service to another, right? We have an action that we need a decision on. And so we have these three parts, which is the input, the policy, and the data, right? Input, policy, and data.
Hold on. So in the end, we're asking OPA for a decision.
Yes.
Easy. And then should this be drawn as a triangle or just as 3 bullet points?
You can draw it as a triangle, but input has to be on the top. That's typically how we always draw it. Is inputs at the top, policy and data is at the bottom. Or you can write like Rego, because the policy is always written in Rego. And so, and then in the center of the triangles is always OPA, because OPA is doing the transformation between them.
OPA.
Yeah.
It's gonna be. I can't stop.
The server binaries actually say that every time they make a decision. If you're in the data center, you just hear OPAs nonstop. OPA, OPA, OPA.
Sounds like a great place to be. Cool. So do you want to elaborate on each of these? Oh, we have some nice comments. Kaiwalia says, this is such a unique way of streaming. It's a lot of fun. Fuel Snobble is a big fan. And yes. I'm a big fan of Fuel Snobble. All right.
Yeah. And so the input is always going to be a JSON object. And so that JSON object is coming from that service that's asking a question. So if that's like Terraform, it'll be a JSON object containing the diff for all the changes, right? If it's an API, it might be a packaging of the API request and all of the information like get, post, payload, right? Like all those things, right? So you're basically just taking all of the information for the decision and packaging it up as JSON. And then we're asking OPA to evaluate that. And so OPA is going to evaluate that by comparing it to the policy, which is written in Rego, and any data set you want to give it, right? And so that Rego policy, right, is really just a combing that input JSON data, and it's figuring out what to return, right? So it's transforming the JSON that comes in into a new JSON object. And so sometimes you might just transform it into like a Boolean, like true, false. But other times you might want to do something like generate a JWT token, right? Or create some sort of security certificate, right? And so you might want that policy to actually transform the input into a new JSON object that service can use to complete an action. But at its simplest form, like for CI/CD pipelines, typically you're just transforming it into a yes or no response. And then for data, yeah.
Can I say usually a yes or no response?
I would say that's like probably the most common practice, because like CI/CD is where, at least for me personally, is where I use this most of the time. So you're just kind of saying like, yes, no, continue, stop. So.
Cool. Excellent.
And then this last corner of the triangle is data. And so this data, it could be user data, it could be attributes, it could be, right? It's anything you're going to need to inform the decision, right? If we go back to that no deploys on the weekend, that data is going to be the current date and time, right? If the question is around what resources can Terraform deploy, right? Then this data is going to be a list of things that are requirements, right? Because Terraform doesn't know its own requirements, because those are defined by the user creating these actions, right? And so you have to provide that data. And this is, once again, a JSON block. And so we're taking that data and we're cycling over it with the Rego policy and saying, inside of this data block, I have maybe a list of users that are allowed to have access, and I might have a list of configuration specs that I want to verify is there for any of these deployments, right? And so we are just consolidating that data. You might be doing like just-in-time access where you do an HTTP call, or you might have some sort of like bundling effect where you consolidate this data multiple times a day and then use it during the policy evaluation.
So data is a JSON object that the policy examines when it's transforming the input.
Correct. Yes.
Cool. And then the input gets the JSON object from a service asking a question, and the input sends it to the policy.
The input sends it to OPA, and then OPA has access to the policy and the data, right? And so OPA does that comparison.
So when you set it up, you've written a policy, you've defined how your data is captured and what it looks like. You probably defined what your input looks like too, yeah? Like what that JSON object is.
And that's another tricky thing for users to kind of grasp is what is the ideal way to send an input to OPA? Because, right, depending on the service, you could be sending megabytes of configuration data, right? Like thousands, tens of thousands, hundreds of thousands of lines of JSON data. And so when you're sending this information to OPA, right, depending on how you structure it, is going to highly affect how it's going to process that information. And so when you're learning OPA and you're giving it a JSON object that's 10 lines long, it's very easy for you to read even with the human eye. But when you're sending, pages and pages of information, right, like you have to structure it in a way that is very useful for OPA. And so that ends up being the part that kind of trips people up in understanding, right, like not having nested items, right? If you have nested JSON objects, you might have, right, because now you're doing, you're looping inside of a loop, inside of a loop, inside of a loop, and you end up with this like big O problem that ends up being terrible for performance. But it's something that, right, you end up figuring out over time as you start measuring the performance of your policies.
Right on. Nick, the first one is here from Greece, and so they say we use quite a lot of OPAs in Greece.
Nice.
Heck yes. And then I think what will help me, or what I'm trying to do at guessing, but maybe you could just tell me more directly, is like a more linear experience about how these things are all working together.
Cool.
Yeah.
So then maybe we should jump into a use case then.
Okay. All right. I like it.
So then, right. So I guess the most common one that people kind of know OPA for is an admission controller inside of Kubernetes, right? And so this is one. Gatekeeper is kind of the front runner for OPA, and Gatekeeper is a abstraction layer on top of OPA. So essentially what we're doing is with Gatekeeper, we are converting these OPA and Rego policies into CRDs so that Kubernetes can understand them in a more native fashion. And
wait, hold on. You're a little bit ahead of me. What's being transformed into a CRD?
The Rego policy, right? And so Rego is that purpose-built policy language, and so Kubernetes doesn't understand Rego. Kubernetes understands YAML, right? So we have all these YAML configuration files, and so that's how Kubernetes understands what objects to create or to not create, but right, like that's just the language that Kubernetes speaks. And so Gatekeeper is that abstraction that converts Rego to CRD.
Cool. I'm going to actually. Policy is converted into Kubernetes CRD, which stands for Custom Resource Definition, by Gatekeeper. Okay, cool.
All right. And so with this being our use case and that kind of being the backdrop there, so we have the input here, right? So an admission controller, right? This input is going to be the objects that Kubernetes is trying to create, right? And so it is saying like, am I allowed to admit this object into my cluster, right? This would be pods, containers, namespaces, you name it, right? Like if Kubernetes is going to create it, you can pass this through the admission controller, which is going to say, right, like I approve this resource or I deny this resource, right? Once again, we're back to that yes, no decision. And so that's what this admission controller is trying to do. And so the input is that object that it's trying to create, right? And so now we are bundling up that object, which is going to be, I'm just deciding like how deep down the rabbit hole to dive here. But yeah, like it's going to bundle up. Like let's say we're creating a deployment with a bunch of pods in it, right? It's going to bundle that up. It's going to convert that YAML to JSON, and then it's going to send a webhook. It's going to send a webhook which reaches out to OPA, or you could be running OPA as a sidecar. There's also a lot of deployment models we could talk about. But right, it's going to send that information to OPA, and that's going to be our input. And then so OPA, let's say,
who sends the information to OPA?
The admission controller. So the admission controller is a webhook.
Okay.
And so that webhook can be pointed at OPA, right, in a few different deployment fashions. And so the admission controller basically sends an HTTP call. And so you could be doing that inside of the cluster if you OPA is a sidecar, or it could be external, right? There's pros and cons to each depending on how your application works. And so the admission controller sends that webhook to OPA, and now OPA is going to look into its memory, and inside of its memory, it has that policy, the Rego file, and it has any data that you fed it. And so in the case of Gatekeeper, typically you're going to define those two things. Are you going to define your Rego policy as a config map that OPA can read? And then data, right? You may be doing like an external data source where it's reaching out and pulling data, or you might have some data that's directly coming from the cluster. You might be pulling cluster state. That could be the data that you're providing it, right? And so OPA running inside the cluster is going to say, hey, I know that this is my policy, and this is what I'm going to convert this input to. In this case, it's a create or don't create. And I know like I have this additional data to help me make this decision. And so OPA now says, oh, you're trying to create a deployment with a dozen pods with no memory restrictions. And I know in my policy that it says you have to have some sort of memory restrictions. Otherwise, there's going to be chaos, right? And so like that might be the policy that's defined there. And so OPA will say like, you know what? I don't like these. I don't like these resources you're creating. And so it's going to send a webhook back. It's going to respond to the initial webhook and tell the admission controller, I don't like it. Don't create it. And then the admission controller, right, sends that information back to the developer who made the request in the first place, right? And so now the developer gets a very clear message saying like, you did not define memory restrictions on your pods. And so, right, like this is kind of where we started this conversation of having that fast feedback, right? Like we are now creating policies in a way that nudges an engineer in the right direction, right? So now they're getting feedback seconds after they've tried to create something, right? Without having to waste the resources of actually creating it or right, like so they basically have that feedback right away, and so that's kind of the cloud native fast iteration cycles that we are looking for from the tool. And I think we have another question here. We have a couple questions. So I assume this was for K8s. Yeah, this use case we're talking about is for K8s. And then the second question is for AWS resources, right? Yes. And so it is I'm not sure if you were here at the very beginning, but we said this is a general purpose tool. And so this use case is for Kubernetes resources. But yes, like if you're using CloudFormation in AWS, right, that could be another thing that's creating resources that you might want to control in some way. So CloudFormation, same thing, would bundle up that information. It would say, I'm trying to create, a dozen XL2 EC2 instances, and then it's going to send that information to OPA. OPA will compare that to its policy, and the policy might say, like, we don't allow new developers to deploy XL2s, right? And so then OPA gets to respond to CloudFormation and say, hey, look, this is out of spec. Send this error message to the developer, right? And then they get the information to say, like, oh, look, sorry, you need to make this smaller. You need to make this a medium or a micro or whatever they have permission to create.
Okay, let's make sure I have this right. So in a Kubernetes use case, the policy is converted into a Kubernetes CRD by Gatekeeper. So the inputs, what you're saying now is by a developer, is like, so say a developer wants to create a Kubernetes object, like a deployment. And then the admission controller webhook says, okay, we need to ask OPA if this is okay. And then OPA is running in the cluster. It has this policy and the data and its memory, and it does its calculation to figure out whether it's okay. And then, so OPA does its calculation, and then it sends that answer back to the Kubernetes admission controller. And if it's a fail, it's going to give a reason why for that fast feedback. And then the admission controller will communicate the answer to the user.
Correct, yes.
Is that accurate? Cool.
And so this is kind of like the happy path, easy deployment model, right? And like I said, like there's a lot of optional ways to do this. And so like we could do tangents all day long of different configurations. But this is like the simple happy path of like, okay, this is like a very common way to do it that a lot of people use. And we know that it's going to work very well for you.
Excellent. And it helps me just have like a starting place to start to understand this. We have another question from Fuel Snowball. Can you override policies? I'm thinking in a crisis situation when you need to deploy risky things ASAP because the whole world is burning.
Yeah, and so right, like building that backdoor, right? You can always build one. You can always deploy something in an alternative fashion that maybe doesn't use the admission controller connected to OPA, right? And so when you do this, though, right, this is typically when compliance comes into play, and right, like a big majority of the time when you're going through the exercise of creating a policy tool, right, you're doing this for governance or compliance reasons. And if your compliance reasons say that everything needs to be checked and you're having engineers circumvent the system, then all of a sudden, right, like things aren't compliant to the same degree. So yes, you can build backdoors, but you have to think really carefully as to why are you building the backdoor, and right, like what are the situations that you should allow people to use it.
I have more questions.
Okay.
Kaiwalia says, OPA website describes two different architectures that can be implemented in. Can you give a quick examples of both of them?
Yeah.
And then follow up, do you prefer one to the other?
Yeah, and so there's actually a handful of deployment models, right? And so like in this case, where we're talking about Kubernetes as a sidecar, you can run OPA as a centralized server in server mode where everything kind of reaches out to it. You can also run it as like a hosted daemon, right, directly on like a Linux host or something if you want to communicate directly with another process. Or if you're doing like high performance, we have a Go library where you can drop your policies directly into your code, right? And so each of these deployment modes have big benefits and big drawbacks. And so it really comes down to why you are, or what you're wrapping the policy around. So obviously, if your application is running in Kubernetes, or if your application is running inside of Kubernetes, you might want to run it as a sidecar because it's very close. It's very close to that service, right? If you have various applications that are running on various servers, then maybe it makes sense to have that centralized policy point that all the servers can run out to. If you're doing something very high performance on one server, then running it as a daemon process may be the best way for you. And then with the high performance Go library, like that's kind of, you're doing something very special. And like I was just on I did a call with the team over at Miro, and they have this like they have the Miro board, which has, dozens of users and hundreds of objects. And they're feeding all of those interactions through like a Kafka pipeline that goes into that hits the Go library for OPA and processes all those decisions to know when things should change. And so it's a really cool like use case, but it's not where people start, right? And so like the Go library is like, you can do amazing things with it, but the complexity there is very high. And so like typically what we see is if you're testing stuff, you start with that like daemon process on Linux, and then you kind of decide like, all right, do I want more of a centralized model, or do I want a distributed model, right? Like, so like the sidecar, the server model. And then when you get to a point where you have massive scale or a very specific use case, then you'd go to that Go library. And that's kind of like when you would use each of those.
Kubernetes sidecar for if it's distributed, Go library for high availability,
high performance
server, high performance.
Yeah. And so
centralized server for when? Can you give me a quick,
centralized server for kind of ease of deployment. It's just like a simple architecture model.
Okay.
And then daemon process is, I would say normally it's just like for testing, right? Like that's kind of, okay. You can find other ways to use it, but that's normally where you will start.
For testing OPA or for testing your applications and using OPA as part of that?
I would say testing your policies, right?
Testing
so you might
policies,
be testing that.
got it.
Yeah. So like testing, if you want to like have like a unit test or something, or you want to like run something locally, or you just want to, right? Like it's kind of like a very easy way to like set that up to where it's just like, oh yeah, let me run this next to the service and kind of have it ask questions. Once again, you can do more complex versions of that, but that's, when I'm using it, that's typically how I do it. I'll run OPA directly on my Mac and then push policies towards it and ask it decisions.
Cool. Fuel Snobble has a lot to say. So Fuel Snobble has actually been a guest on the show before, and what they talked about was incident management. So
nice.
Fuel Snobble is, So it said, I agree in principle with what you said before, but definitely been in situations where things are burning. They were DDoSed once, and that was intensely hectic, and the whole system was down, receiving tons of direct messages and data loss for each second the system was down. So
And in that case, right, like in the situation where you have a DDoS, right, that might be a situation where you're wondering why the DDoS didn't hit the policy first and like drop a lot of those things, right? If the policy is blocking you as the engineer versus blocking the attackers, right, then you might want to reconfigure a lot of those policies to kind of filter through a lot more of the incoming actions. And right, this is something that for compliance reasons, especially for companies that are heavily regulated, right, we also track every single decision that Open makes, right? And so you have these decision logs that are just massive because it's not asking for like per developer click, like we're asking for every interaction of every user on the system at any moment, right? And so like you have these decision logs that are just like crazy large.
Cool. This is great so far. I'm learning so much. Where would be a good direction to take it next?
Yeah, and so this has been a great start. So we've done kind of kind of like the triangle. We have the admission controller use case and deployment models. Let's see here. What else do we have? So I guess when like tying this back, right? Like we have this one use case for the admission controller, but it's not the end all be all for OPA, right? Like what we are ultimately trying to design here is a unified policy story. And so it's kind of, what does it mean to have a unified policy story, right? This is why OPA was initially created in the first place, is right? We have one use case, which might be admission controller. We have another use case, which might be like RBAC or ABAC, right? Like deciding what users can do what things. And so when we're talking about a unified policy story, right, we are now trying to decide how to implement these policies across the stack, right? And so this is kind of the power of Open Policy Agent, is that you're able to do this with one tool set and one language in various places, right? And so that's kind of the trade-off that we typically see when people are evaluating other policy tools that exist now in Open Policy Agent. It's, do I need a tool that's specific for admission controller? Or do I want a tool that's extensible to the rest of my cloud native stack, right? Like, am I only caring about my Kubernetes resources? Am I only caring about, right, like maybe my Terraform resources? Am I only caring about my resources in Azure, right? Like, because each one of these tools has a policy language, right? They all have their own version of OPA, but these versions of OPA also only work for that tool. And so this is one where actually HashiCorp, right, they have a policy tool called Sentinel. And so with Sentinel, right, it works directly in their cloud and natively integrates to everything. But they built in a native integration for Open Policy Agent because there's enough users asking for it that they're like, oh, well, I've already written all my policies in Rego. I'd like to also use them here in Terraform Cloud. And so, right, like I think HashiCorp is amazing at taking like community feedback. And so they basically just built it into the platform, which was cool. And so, right, like, so now we are defining this like unified policy story, and we are trying to understand at what points throughout our organization and our application do we implement policy, right? And so now it's not just a technological decision for that one application, it's, right, overall architecture. And so you end up thinking about how many times is a decision made when a user uses your application, right? That user, hits your website, then they log in, then they do something, which each has its own action, right? And then when that happens, your application is now reaching out to dozens of other services, right? So you can see how very quickly there are dozens of decision points that need to happen just for a user to use a system. And so this is like the interesting bit of the unified policy story, is like, so how do we now define this in a way where these policies are able to kind of spread out and kind of disseminate throughout your system so that you have that view of what's going on and what should happen and when it should happen.
So you've asked a lot of questions, but what's the answer? Like, how do you begin? It sounds like a huge undertaking to figure out all of these decision points. Like, what's the strategy?
It definitely is. And the strategy, like with most things in technology, is like start small. And so we normally say, don't start with like your production data, right? This goes back to like Fuel Snapple's thing about, like break glass. You don't want to like put yourself in the first place with like a break glass scenario. You might start off with, let me wrap policy around one of these community extensions that were built, right? And so those community extensions, right, they're not mission critical. You might upset someone if people aren't able to access them, but it gives you a great starting point for someone to implement OPA in a
Mm-hmm.
non-critical way, right?
Mm-hmm.
And then once you start small, now you have a base policy and you understand how the system works. And now you just start expanding and extending, right? So now it's like,
Mm-hmm.
okay, well, let me try something a little more useful. Let me try to put something into my CI/CD pipeline, right? And so
Mm-hmm.
now you might have resources there. And then so you could start working your way closer and closer to more critical services, right? Until you are running these policies in production in a way that you know is safe.
Mm-hmm.
Yeah.
Cool. What's an example of, oh, I guess Kubernetes and Terraform is a great example of where you need more than what's just available in Kubernetes. But like, and then cloud providers too have their specific tools.
Yeah, everyone kind of has
Okay.
like specific data that is very specific to that cloud or tool or service, right? And then so like when we're not talking resources, if we're talking more user information like ABAC or RBAC, like roles-based
Mm-hmm.
access controls or access-based or attribute-based access controls, right? Now we are defining things purely based on things that are happening for those users. So it's not even about the environment. It's like, oh, I actually want to define, right? Like admins and root users can do these things. Or it's like attribute based where, hey, I want to make sure that it's requests are only coming from this location, hardware matches this specific numbers, or it's like you can get very specific about how you want to use or how you want users to interact with your system, right? And so that's ends up being a very big rabbit hole. It kind of goes down the whole like
Yeah.
zero trust model, if you will. It's trying to understand like, oh, well, I want every interaction now to be evaluated in a way that means that no one is granted trust just because they've already
Mm-hmm.
done one action or another. Every
Mm-hmm.
action has a decision that's
Uh-huh.
specific to it, right? And so if you wanted to get like that granular, right, that's
Uh-huh.
something that you could do with OPA, right? But you're building a lot of very small details into the process. Mm-hmm.
That seems heavy. Like it seems like a lot of processing, a lot of
Yes.
compute. Yeah.
And
Uh,
that anytime you're doing like a zero trust model, you're basically doing heavy compute on it because it is right. Like you're essentially saying like if there's no trust in the system, we have to make sure that every request is kind of validated. So you end up adding
uh-huh.
a lot of checks, right? Versus like
Uh-huh.
the old model, which was like, oh, anyone who's kind of come in the door already, trust them to do
Uh-huh.
whatever they want to do, right? And
Yeah.
so it does add a lot of overhead,
Yeah.
but yeah, like that is something that like to the very if you want to take things very fine grained, you can
Uh-huh.
dig into that very specific level.
It's like the opposite of the wiki, but they
Yes.
both
Yeah, the wiki was kind of like full trust. We believe that you will do all of these things, and now it's like now we don't believe anything you say. We're going to check for ourselves.
What other trade-offs can there be? What other lines are people looking at with implementing policy? And
Yeah, and so I think I mentioned this earlier, right? We have the trade-offs here between like performance, readability, and extendability, right? And
mm-hmm.
so with these three things, you are right doing things where you, at its simplest, you might just want to create something super fast that's highly readable, but you're not necessarily thinking about how performant it is, right? So you're just like check object for X, and then check any objects inside of that for X, right? So now you're taking these huge performance hits by having these nested lookups, and so
Performant readability, what's the third? Is it speed?
Extendability.
Extendability. Is
Yeah.
this like fast, cheap, and good? Pick any two.
Kind of, sorta, in a way. Like you could, like you kind of sacrifice, like readability is kind of the easiest thing to do. You can make things very legible in a way that's like, oh, it sounds very close to English.
Mm-hmm.
But then, right, then you start measuring performance, and then you're like, oh, let me actually rework the data so that it can, right, not go through these iteration cycles, right? And you're going through loops over and over and over again, right? And the opposite side of that is extendability. You might not have constructed your policy in a way that's very easy to reuse sections of it, right? If you've already
Uh-huh.
written policies, let's say in AWS, if you have a bunch of policies around EC2 instances, right, you may
Mm-hmm.
not want to rewrite those, right? And because
Mm-hmm.
Rego is a full-featured policy language, you may want to reuse a lot of the things that exist, and you can reuse
Mm-hmm.
those by packaging in a way that is referenceable from another policy, right? And so, but then you're now sacrificing a little bit of that readability because now everything isn't in the same policy. Now you have multiple policies constructed in a way where you're making calls between them. So you have that
Mm-hmm.
ability to reuse a lot of that code. But right, you are
Mm-hmm.
sacrificing a little bit of readability because now it doesn't live in the same page. And
Mm-hmm.
so, but yeah, I guess readability is normally the one that kind of takes a little bit of the hit when you're trying
Mm-hmm.
to improve performance or extendability.
And
And
then
so,
would you maybe already said this, but what's an example of changing a policy, like optimizing a policy for performance?
yeah, so like a big one is like not doing a lot of external calls, right? Like because
Okay.
OPA saves everything in memory, if it has to reach out, that ends up being a big performance hit. And also
Mm-hmm.
reusing data. If you've already checked an object, you
Mm-hmm.
should save that information as opposed to checking that object again for the next rule,
Mm-hmm.
right? And so a policy is constructed of rules. And so each policy can have any number of rules in it. And so those rules, right, each rule might be running the same check if written badly, right? Like, so
Uh-huh.
the first rule might say that uh, make sure that these labels are on this resource, right? And so you might check that object for labels. And then the second rule might say that make sure that these resources have this naming convention, right? And so are you
Uh-huh.
rechecking those objects again, right? Like, so you can go through those same checks multiple times, or you might save that resource list as a
Mm-hmm.
set. And then now you can just do set lookups and verify what things exist inside of
Mm-hmm.
the resource list. That's like a much more
Mm-hmm.
performant way of doing it.
Mm-hmm.
And so, right, like there's a lot of those performance trade-offs that, but from a readability standpoint, you're just like, I'm thinking in this linear fashion, and I just want to go down this list
Mm-hmm.
of things. That's kind of how you write it at first. And then
Mm-hmm.
as you get better, then you start going back and saying like, okay, well, I'm running the same checks multiple times here. I can save information here.
Yeah.
This is a nested lookup, so I can split this and only check this once here. And so it ends up it ends up being I guess the confusion point for a lot of OPA users when they go from like 101 into like 200 level is like, okay, well now I'm constructing things in a way that has to make sense logically and not just
Uh-huh.
linear fashion of me reading through my policy.
Okay.
Yeah.
That's kind of like learning to code in general, I think.
Yes, it's like learning any language,
Yeah.
especially learning a declarative language,
Thank you,
right? Like,
Ron. Thanks for being here. Yeah. Sorry.
and so yeah, like
Yeah.
I compare learning Rego a lot to like learning HCL because the
Uh-huh.
first time I learned HCL, I was like, oh, okay, well, I right like
I don't know what HCL is.
oh, sorry. So HCL is HashiCorp language.
Okay.
Yeah, I'm pretty sure it's HashiCorp. But anyway, it's the language used for Terraform, right? And so
Okay,
that
got
was
it.
like that was the first declarative language that I used, where it's like, okay, I am declaring intent of my resources, and not just
Uh-huh.
like at its simplest form, you're like, okay, I write one resource, it creates one thing. The
Uh-huh.
confusing bit is once you're doing configuration inside of those resources, then now you're like,
Uh-huh.
oh, I want things to exist inside of these resources. And so that's when you start learning, right from the declarative nature, things need to happen in specific orders, but you
Mm-hmm.
need to define it in one way from this declarative language that ultimately creates that output that you're looking for. And so OPA
Mm-hmm.
does a lot of that for you, right? Because it is declarative. You are looking for the output, which is like secured resources or data or whatever. And you just
Mm-hmm.
have to define the policy in a way that filters out all of the noise and all of the bad stuff and
Mm-hmm.
declaratively states like good stuff has come out the other end.
Yeah,
Mm-hmm.
I like that. Kaiwa, yeah. Where can I find the contents from this boards? These are way better notes than I take. Thank you. I have a thread on Twitter where I post all the boards of photos of all the boards that I've made. So there's almost, I think we're getting up to episode 50. It's been a while. So
Wow.
if you follow me on Twitter, which I can just stick the handle up real quick. And both of us follow Peter too while you're at it. So it's Wiggity Whitney on Twitter, and there's a thread there, and I'll add this one to that thread. All right. Um, there's so much here. This has been really great so far. Do you want to talk maybe a little bit? Well, if you have more that you have that you want to cover, we should go with that. But if it's up to me to decide, maybe talking a little bit more about policy generally, or so I have another show called You Choose, and I'm actually starting a series of episodes about different policy tools in the CNCF, and there are 7 of them. So
Yeah.
what might you be looking for when you're choosing a policy tool, or maybe the policy space more generally? If you want to focus on OPA, that's fine too.
No, let's move into the policy space here, right? And so it's an interesting conversation. I've done a handful of talks kind of just on like policy as code, right? And
Mm-hmm.
so because Rego is a declarative language, right? It does essentially do policy as code by default, right? Like, and it's
Mm-hmm.
so when we're talking about policy as code, we are
Mm-hmm.
introducing a lot of the practices that we call GitOps, right? And we're superimposing those onto our policies now. And so
Mm-hmm.
this is something that you're going to want from any sort of policy tool in the cloud native space, where you have those practices of your policies are defined in a way that you can check into some sort of Git version control. And you can always understand at any point in time, what does your policy, what is your policy doing at that point in time? Right. And so having those version controls allows you to have that historic look back and roll back if necessary. Right. And so
Mm-hmm.
we have when we're writing Rego, the optimal way to do this is, right, you write your Rego policies, you check them into your Git system, you merge that branch, and then it gets picked up by whatever your policy server is. It's going to serve that to OPA, right? And so this allows you to have things like unit tests on your policy, right? It allows you to
Mm-hmm.
have checks that confirm whatever you're doing isn't going to cause more problems than solve the problems it's creating, right? And so we are introducing a lot of those concepts into those like best practice coding concepts into your policy creation. And so this is something that I would look for from a policy tool, is that you're able to have a lot of these best practices and you're able to create a policy development lifecycle. It's very similar to your software development lifecycle, right? Because you want to do the things, or you want engineers to continue to use the tools they already have, but just
Mm-hmm.
adding in a new thing for them to work with, right? So now you're adding in policies, but you're not changing the flow of work, right? The flow of work
Mm-hmm.
for developers, right? Like you think of the thing you want to create, you test it, you create an example, you push it, you test it, and then it circles back around, right? Like, and then you think of the next thing and you iterate on it, and then you test it, you deploy it, and then it circles back around, right? And so you're continuously in this like iteration cycle for your software. And it's very similar for your policy, where as new information gets introduced, you have new things that you might want to implement in the policy. And so you're continuously iterating on what your policy is doing. And you never want your policy to break what's happening in your application or in your organization, right? And so you have these modes of working that work very well for software that also work for policy. And so this is something that is very powerful from this construct that I think kind of gets overlooked a lot.
So we have policy as code, making sure it's declarative, which enables GitOps, and then best practices should be defined as part of the policy. And again, that's implemented, the implementation is triggered with GitOps if it's done declaratively, which it would be if it's defined as part of policy. And then you were talking about policy lifecycle management. So that's like updates to your policy, don't break things.
Yeah. I like how you're like drawing yourself into a little box now.
Yeah. I'm sorry.
I was like, oh, I wonder why that bullet point is indented. I was like, oh, because her head is there.
I have nowhere left to go. Updates to policy doesn't break things. Is that enough to say about policy lifecycle management?
Yeah, I think from like a general concept, like that kind of covers it. I've done a talk on like policy lifecycle management by itself, where it's just like getting into the very specific details of unit testing and auditing and revisions and so many different things. But like from a high level there, it's like, yeah, like just making sure you're able to like iterate on your policy and introduce new ones without breaking things.
Yeah. Great. Cool. Is there anything else like in a policy tool that one thing you said earlier is like, you're saying, I'm sure I'm going to get the other side of this story from other tools, but you're saying that like one language across for Kubernetes Terraform cloud provider is a feature. How would you wrap that up in a generally speaking policy tool that you can write? Yeah. How do you write? Yeah.
Yeah. So I guess like saying that in a concise bullet point there is not like, don't reinvent the wheel, right? Like if you have your policies, you can have your policies defined in one place and you don't have to, right? You just have to figure out how to integrate the new tool. You don't have to figure out how to write your policy a second time, right? And so it is.
So that actually goes off to your like centralized policy storage and management also, in addition to the language or implementation agnostic.
Yeah. And so that's one where, like there are trade-offs there because policy specific or tool specific policy tools. Yeah. Essentially, right. Like they're able to integrate in a way that's much simpler for that specific use case. But then that's where the trade-off is. It's like when you're writing this policy for this one thing, it's very easy. But now you have to write that policy again for another place and then another place. And so you have to end up writing it in 4 different ways. And you need someone who's able to do that translation. And then you also need a process that checks all of those places and does 4 different things for one policy, right? And so when we're talking about Open Policy Agent, you're talking about, oh, I just need to define my policy in one fashion. And then I just need to get my tools to ask the question in the right way, right? And so you're basically changing, you're just changing the point at which you're converting the data, right? Yeah. And so, yeah, like that's definitely the biggest trade-off. I think speed versus, I guess, well, initial speed versus long-term velocity there is how we like to look at it, where you can get you can get started with policies much faster with a tool made for a specific use case, because it's made for that use case. So it's very fast to get started. And then you slow down once you end up having a lot more things introduced into your policy, right? And so that's actually where using OPA and Rego, you speed up. You lose a lot of time you lose a lot of time to the initial inertia, because you have to learn this new tool, you have to define everything, you're building from scratch, and so nothing is there for you to use, and so just everything is bespoke to that configuration. So you spend a lot of time up front, you don't have the momentum. But once you've iterated and you've gone through those cycles, now that you have the momentum, that's when it becomes a much faster tool. And that's where other tools tend to slow down, is that they get to a point where you're like, oh, well, now I need to integrate with 4 other things, and I'm importing that data. And how do I do this? And how do I do this in a way that's going to be understood by the tool? And so you end up having to create a lot of stuff that slows it down, right? And so, but this is the point that all the policy tools will probably argue on. It's like where's the speed loss in the policy development?
So tool-specific policy tools can be easier to get started, but
yes, like it's a much faster ramp up.
But then hit a ceiling.
Yeah, so like I would say that like Rego basically accelerates once you have that base built and you want to integrate more. That's when you see the policy development cycles kind of speed up, because you've already created a base to work with. Now you're just extending on top of it.
Across whole cloud environments. There are, I am seeing more, especially hanging out with Victor Farsik. He advocates for doing everything in Kubernetes. So instead of using Terraform, instead of using cloud provider tools, or maybe you would use cloud provider tools, but you'd integrate them into your system using Crossplane and keep them Kubernetes native, the whole, use Kubernetes resources to manage external things. And if you're doing something like that, then you could conceivably use a Kubernetes specific tool. But that's, a lot of people probably already have their stuff very built. Yeah.
Right. And so like that argument, I think, is very valid for maybe a smaller company or someone building a new project where you have the luxury of building everything Kubernetes native from the jump. Right. And then it's just like, that makes a ton of sense. And if I was building something from scratch, I would definitely do that. But this goes back to kind of what I do for my day job, is we're doing digital transformation, because people built these applications decades ago. And now they're trying to be cloud native. And you can't just go, you know what, we'll just rebuild it. Because there's so much tech debt that they need to bring into this new cloud native thing. And it's not a one-to-one conversion. And so all these little pieces, right, that's where the pain is felt. And that's where people end up wanting to pick up a tool that does general purpose, is because it's like, they don't have the luxury of just going, you know what, shove it all into Kubernetes, right? A lot of times they may not even have the in-house knowledge to use Kubernetes yet, right? And so it's a very slow process. And yes, I agree. In the ideal world, you can definitely build everything with the best, newest, shiniest tools, and that would be amazing. But for a lot of engineers, they have a lot of weight that they have to drag into the new things that they're building. And so that's where the struggle is for a lot of engineers that don't have that luxury.
Yeah, that makes so much sense. I'm very interested to learn about how there are 7 different tools and how the 7 different things that are being solved.
It's going to be a great policy battle royale.
Yes. So we have a little bit of space on the board. What do you think we should dedicate this to?
Is this so we have this little bit of space. Is this typically like, do we draw like a little piece of art? Do we draw the little open sign, or do we like
Don't-
find one more technical thing to talk about?
Probably one more technical thing, or we could recap something. Also, it's common to talk about like what's coming up in the future. What's something that some brand new features or something coming up, or how to get involved in the community, or
Yeah, let's talk about kind of how to get involved in the community. And so there's quite a number of ways there. The
okay.
most active chats are on the Slack channel, right? So that's openpolicyagent.org/slack.com. Then there is obviously GitHub for anyone who wants to get involved in the development of it, who wants to maybe write a feature or build some built-ins. That's actually one of the easiest ways to get started in the development community is to create a built-in. I mentioned this near the beginning of our talk, where we have 150 built-ins now. A lot of them contributed by community members who had specific use cases. And so these built-in features might be like, oh, I want to work with encrypted data, or I want to work with JWT tokens. I want to work with whatever type of information you want to put in your policy. And so community members will say, oh, hey, we're at our shop, we do X, Y, and Z, and it would be really great if we can just have a tool built into the language that does that. And so, right, like you can add those tools pretty easily. We have some developer documentation that'll help you get started on how to build that built-in. And then, yeah, we also have our discussions board for more like ongoing technical discussions. Maybe it's not quite or not yet a feature request, but you want to say like we're talking potential solutions for how to use something. The discussion board is a great place to have those conversations. And so
where do you find the discussion board?
Oh, sorry, GitHub discussions.
Okay.
Yeah. So it was, yeah, like GitHub discussions was like I set that up like when GitHub announced that they were adding that discussion board feature. And it's been a very interesting development to watch that thing kind of go from very bare bones to like, oh, it's like it has all the things you would want from a discussion board now.
Oh yeah, GitHub's good like that, huh?
Yeah.
Cool. So we have a lovely comment from David Michael. This was amazing. Thank you. Thank you so much for sharing your time and attention with us. Yeah. So what I would like to do now is repeat everything you've told me in my words to make sure that I have a clear understanding of everything you've come here to teach today.
Perfect.
And then, just fair warning, Fuel Snobble kind of mentioned we're gonna dance our way out at the end. So
I did like skim some of these videos, but I don't remember skimming over a dance off.
So all we're gonna do is when it's time to say goodbye, we'll replay the intro music and we'll dance for a little bit while we say our goodbyes.
Sounds good.
Great. So let's recap though. So before open policy agents and before policy tools in general, there are some hacky ways that people were trying to implement policy. So they might hard code it into their applications and services, or they might just have a wiki, just some nice suggestions. You know what? We'd please like for you to do this.
Yep.
I'm sure that was very, sure it was very effective. So there's definitely a need for policy automation and also policy automation across a whole stack. So we talk about it a little bit at the end, but defining your policies in one place that then those policies can be used over and over again. So, decoupling policies from the applications and services that need to use them.
Yep.
So open policy agents, called OPA for short, is a general purpose policy engine, which is a very, I understand why that needs to be the definition, but it's just not very satisfying as a new learner because it says so much that it says nothing at all. But that's part of the point. Like it can be wrangled to do many things. So Rego then is the declarative purpose-built policy language written specifically for OPA. So by purpose-built, it's kind of redundant. You mean written specifically for OPA.
Yeah.
And then as it's matured, there's been more and more syntax added to make it human readable too.
Yep.
So then we talked about three parts to a policy. So basically, in the end, what we're doing is asking Open Policy Agent to make a decision for us
Mhm.
about anything. That's part of keeping it so general. But let's just say the most common way is to ask whether this resource is allowed to be created or updated in a specific way.
Mhm.
So there are three things that we need, the three parts to the policy. One is, what is the input? So what's in the resource getting created, for example. So the input's going to be a JSON object. It's coming from a service and it's asking the question. So the input is the question, and that
Yep.
goes to OPA. And then OPA has already configured a policy, and the policy is where Rego comes in. It's written in Rego. And so it combines JSON data from the input, and then it transforms it. So it has the policy, and then it has the data. The data is a JSON object that the policy examines when transforming the input. So, so it's going to use the policy and the data together to come up with an answer for the input.
Correct. Yes.
Yes. So a common use case for this, which will help crystallize it, is Gatekeeper, which is an OPA abstraction layer on top of Kubernetes, and it's an emission controller for Kubernetes. So with Gatekeeper, policy is converted into Kubernetes CRD, a custom resource definition for Kubernetes. So this Rego policy becomes a CRD.
Yep.
So the input is the Kubernetes object that a user, will say, developer wants to create. So let's say a deployment. That's the input. The developer is like, hey, yo, I want to make a deployment, please. Thank you. And then the admission controller webhook sends that input to OPA. And then OPA it has its policy and its data. It already knows those things, and it's running in the cluster. So then it does its thing. It makes a decision about whether that developer should be able to make that deployment. And then it sends the answer and the reason for the answer back to the admission controller. And then the admission controller will tell the developer, yes, you're allowed to make this. Good job. Way to follow our wiki page. or sorry, yo, you can't do it. And here's exactly why. So now you're learning from your experience.
And so that reasoning is actually like written by the policy author. So you could be a bad policy author and not write a reason, and then you're in just as bad a spot. But yes, if you're a nice policy writer, you're going to write reasons for why you're turning things down.
Yes, makes a lot of sense. So we had a great question about how to deploy OPA, like how is it actually used? And so we talked about those ways pretty briefly, but you can use it as a Kubernetes sidecar, which helps you have a distributed version of OPA. You can do a Go library if you want a high performance version of OPA, a centralized server if you want to keep it easy peasy, or you could do a daemon process if you want to test your policies. Yeah. Those are some ideas there. And so then we talked about having a unified policy story in your organization. So we want all kinds of teams across a larger organization to have to know what their policy is about, know what the organizational wide policy is about. We have David Michael has a comment. If you're a nice policy writer, you will. Any links to more specific tips like these? I don't quite understand the question, but
I think David might be asking like as a policy writer, what other things should I include in there? So reasons are one easy thing that's very common practice. You write a set of reasons, and then you return one of those reasons for your denial. Another thing is metadata or annotations inside of your policy. This is like clean code practices, right? And so we have a lot of this stuff in the documentation for OPA. But yeah, go ahead.
If a policy is tied to a specific resource, we're talking about like a centralized policy store where policies can be reused. But if one's tied to a specific resource, it would probably be good to somehow link it to that resource with labels and selectors or something. So if that resource gets thrown away, the policy isn't still living on the cluster with attached to nothing.
Yeah.
Just a thought.
Yeah. And so like you have organization of like maybe packages of policies. And then inside of that, you have like annotations for things that it's connected to. And so there's
Uh-huh.
a lot of ways to kind of subdivide and organize the policies. So yeah, but a lot of the options are in the documentation, but the
Uh-huh.
best practices probably aren't defined as well as they need to be.
Ironically.
Yeah, but all the options are documented.
All right. So unified policy story, like ideally, all the teams in your organization have a sense of your organization's policy, or at least how to implement that policy. If they don't know exactly what's happening, they at least know how to apply the policies they're meant to apply to the resources they're making. So implementing policies across the stack and across different teams. And then this is with OPA, it has the advantage of having one language, that Rego language for everything. And so that means if you have Kubernetes cluster and are using Terraform and are using cloud provider specific resources, no matter what it is, you can always define your policy in Rego. And because of that, you can have a centralized policy store that then people from different teams can consume from. So the same policies can be used over and over again for different resources. And then we just kind of generally ask, like, at what points do organizations implement policies, and where are decisions being made? And it sounds like there are decisions being made all over the place, every little teeny step of a call, a request. So you do want to have like some sort of awareness about how granular you want your policies, and awareness of how much compute kind of overhead that's going to take to implement that, not to mention to maintain it. So if you do want to start implementing policy and you haven't yet, a good way to do is to start small and start with stuff that's non-critical. And then as you get good at it and confident in what you're doing, you expand. And then, as we just talked about, it's possible to have a zero trust system, but it would be expensive to do it too. So when you are implementing policy, you want to think about these three different things about keeping your policies performant, keeping them readable, and keeping them extendable. And you might have to sacrifice one to optimize another. That's why it's labeled trade-offs. So for performant, you might want to minimize the external calls you need to make for a policy. You might, in order to do that, you might want to reuse data. For readability, it's just, can a human being figure out what's happening if they're digging in later? And then extendability is, again, talking about one policy for many use cases. So then we talked about policy tools. Generally speaking, this is the first of a whole series I'm doing on all the CNCF policy tools. So we have an OPA opinionated version of what we're looking at for, generally speaking, but it's something I will bring to the future episodes. I'm very grateful for this conversation. So definitely having a declarative policy as code. This is going to enable GitOps. And then if you have your company's best practices defined as part of policy, then that also can then be enforced by GitOps, or at least the enforcement's triggered by GitOps. You also can define your policy lifecycle management. So you have ways of ensuring that if you update an application or if you update a policy, that things are not going to break. And again, a third time, the policies can be reused and stored centrally in the system. And then policies should be able to be accessed by any tools that needed them. And we talked a little bit about how the Rego is great for Kubernetes, Terraform, like when we're using lots of different tools, but it is possible to have tool-specific policy tools. And there are sometimes use cases where that might be better than Rego. But a lot of times, if the company's been around for any amount of time, they've probably built a lot of different things. And Rego is nice because you can use one language across the whole estate. And then finally, we talked about OPA community. If you want to join and hang out, there's an OPA Slack workspace, OPA on GitHub. We talked about Rego built-ins. There are 150 built-ins that people have made as part of the language for some sort of use case that they wanted. Go ahead and let's make it 151. Go ahead and get over there. Make a pull request. And then there's also a discussion board on GitHub. And Does that feel accurate? Is there anything you want to say or update?
That sounds good. This was a very encompassing session of like touching on all the points.
Excellent. Good. We have Kaiwalia said this was so interesting, and thank you so much for the amazing session. Thanks for being here, friend, and thanks for asking good questions. I appreciate you. Thanks, everyone. I think it's time to dance. Are you ready to say goodbye and dance, Peter?
Okay, do I dance left to right or right to left? Is there a certain way to dance out of here?
You do it in your heart. Yeah. maybe like walk down some stairs.
Oh.
Goodbye, everyone.
Bye, everyone.
Thank you for being here.